Assalamu alaikum everyone. So lecture number 9, and we will be talking about communication networks. So let's start. So as we all know that whenever we talk about wireless communication, wireless networks or wireless computation, so we need an infrastructure. We need some enabling technologies. So in order to have those infrastructure, enabling technologies and computational environment, we need to learn some of the concepts that actually is helping us in order to build or have wireless infrastructure or wireless communication or wireless networking. So we will be going through those different set of infrastructures, the techniques, the technologies that actually act as an enabling technology, or you can say backbone for the wireless communication. Because whenever you want to have a wireless infrastructure, so there is a huge backbone that is supporting enormous data communication, and over that we are building the wireless infrastructure in order to have wireless communication or wireless computation. So first of all, we need to know wireless communication. As we all know that we define wireless communication where we don't need guided path, right? So in wired communication, the data is transmitted or guided along a path, but in wireless communication, data is transmitted along the physical channel, but it is not guided, so we need to guide them. For that we use a lot of different techniques. For example, we use line of sight communication, and there are a lot of other techniques. So we are also aware of the fact that we have electromagnetic spectrum, and we need to use certain frequencies, certain bandwidth and certain spectrum over the electromagnetic radiation spectrum. So we should know the spectrum in details, that what are the limits, what are the bounds for us in order to have communication or in order to use that spectrum. So normally the energy is transmitted in the shape of electromagnetic radiations, and this energy is propagated in free space or air or in water. So the examples of the spectrum which are interesting for us, they are microwave, radio frequency, and so on and so forth, right? So we can also have infrared and other neighboring spectrums. And in case of wireless communication, there are different modes of communication we can achieve. First one is simplex, and this is only one-way communication. And in simplex, data can be transmitted from one point to another point in only one direction. So you can also say this is a sort of directional communication. This is as an analogy, you can take the example of a one-way road where you can go in one directional, but the other direction is not allowed. And one of the best example we can have is our radio receiver, where we can only receive from the source to the destination, and the destination is our radio receiver. And another example is that of a TV. You have idea that in TV we have simplex communication, only one-way communication. Then we have half duplex, though it's two direction, the communication is two-way, but at a time only one-way communication is allowed. The communication is one directional, one direction is allowed. But the communication cannot be achieved or attained simultaneously. So the example is push-to-talk radios, walkie-talkie, and then finally we have a full duplex. It's a two-way communication, and both parties or both the endpoints, both the end devices, they can communicate with each other whenever they want. So the example is our cell phone, and whenever we are talking over a cell phone, and the end users or the people who are communicating with each other, we can have at some stage we can have full duplex communication, and you can feel it. Somebody is talking, and suddenly the other person who's on the other side of the call, he wants to respond, he can respond at the same time. So simultaneous communication is possible in full duplex. And when you have full duplex, so of course you need to use some techniques in order to use that channel for simultaneous communication. So for that we use frequency division duplex and time division duplex. In the first mode, we are allocating frequencies, and in the second method we are allocating the time slots for the endpoints, for two legs of the calls, if we are talking about a cellular call. So this is the question which we can pose to ourselves, that why we should use wireless communication. One of the main advantage of wireless communication is its mobility, right? So we can have any service, any time, over any technology. So while we are roaming or we are moving around. So that is one of the biggest advantage of wireless communication. Any service, any time, over any technology, and in addition to that, we can have all this while we are roaming about or we are moving around. And then nowadays we can say that we have wireless communication at a lower cost, but a decade before, or maybe 5 to 6 years or 7 years before, we cannot claim that, because at that time it was not cheaper, and the technology was costly, and we don't have expertise in order to build the infrastructure for wireless communication. But nowadays we can say that the wireless communication is cheaper. And then you know that nowadays people prefer wireless services as opposed to the wired services. One of the best example in our country we can have is, if we have to choose a telephony line or telephony link or telephony service, we will straight away prefer wireless, or you can say GSM, as opposed to the PSTN lines, because it's we don't need to lay infrastructure, wires, cables, connector. We will straight away go to some carrier and will ask for the GSM connection, and within few moments we will be having the telephony service at our doorstep. So these are some of the reasons that why we prefer or why we use wireless communication. So this sort of question should come straight away into our minds, that why wireless is different than wired. So if we talk about the wired media, so we can control its characteristics, because whenever we are building the wireless or creating the wireless media, or we are developing the wireless media. So few of the characteristics we can control. For example, we can shield it in order to avoid the electromagnetic interference. We can also build the jacket or the cladding in such a way that the environmental conditional parameters, temperature and pressure and some other parameters, they have very minimum effect on the wired media. But on the other hand, if we talk about the wireless media, that is air, atmosphere, or maybe water, so we don't have the capability to do that, right? So this is a sort of natural media, so we don't have control, or we cannot build that sort of media. So it's natural, and we cannot avoid the effect of temperature on free space. We cannot avoid the effect of rain on this media. So as a result, in case of wireless media or wireless communication, it's much noisier than wired media. And then of course the wireless media is shared. Each one has its own bandwidth allocated, right? So that's why if we talk about or look at the electromagnetic spectrum, so it's very scarce resource, precious resource, and we should use it in an effective and efficient way so that we can make use of it maximally by using or by having maximum data rate, right? So we need to develop different techniques, different methodologies in order to share the common channel. And then as I have mentioned that we have bandwidth allocation for different spectrum, so we have a limited amount of bandwidth, and we need to use that bandwidth in an effective and efficient way. And lastly, we have to develop signal processing techniques in order to retrieve the signal, in order to detect the errors, in order to correct the errors. So we need to develop DSP, signal processing techniques in order to. So these are some of the standards that are being used in cellular communication. First one is 1G, and within that, AIMS-4 was a very popular communication standard. And then we have 2G, and here we have more data rate. And then as a result of GPRS, General Packet Radio System, the method was enhanced to 2G, or you can say 2.5G. And then we have 3G. So let me share that in 2.5G we have more data rate, and the GSM was evolved to edge technology. And in third generation systems we have internet and voice over IP and other services that are available on cellular communication by using cellular. And nowadays we have the fourth generation that includes enormous data rate, and that is theoretically we can achieve 300 MB megabits per second, but practically we have the capability of supporting 50 to 70 megabits per second, right? So you can imagine the enormous amount of capability in the fourth generation cellular communication. And now people are talking about the 5th generation, and we will be having much more data rate in that communication. And we need to know certain concepts regarding the electromagnetic in order to achieve the wireless communication. We need to know about antennas, the propagation modes, and the channel modeling. Then we also should have some of the main signaling techniques in order to achieve the data that has to be transmitted error freely. And then we also use different communication techniques that includes modulation, demodulation, and then the channel coding. So these all are very important in order to achieve the wireless communication. So whenever we have to build a wireless infrastructure, we need certain enabling technologies in order to achieve that. So you need digital integrated circuits, and we also require RF generation devices, and we should be able to have some of the source coding techniques. And if we want to transmit the signal at a longer distance, so we need to multiply our signal that contain actual data with a carrier. So in order to do that, we will be adopting certain modulation techniques, and then we because the medium is shared in case of wireless communication, so we need to develop multiple access techniques, and then we have to develop or use channel coding, and we need to detect errors and correct errors. And then finally we must have SDRs, that you can say software defined radios or software programmable radios. So these are the enabling technologies, and one of the main enabling technology we should not forget about that is the backbone, right? So whenever we have a wireless infrastructure, so that is on the top, and at the bottom we have the backbone, and that backbone, it support more or higher data rate as compared to the wireless infrastructure. So here is the protocol stack for wireless communication. So you can see that we are using layered approach, right? So at the top we have application layer, transport layer, network layer, data link layer, that is also called MAC layer, physical layer, and at the bottom we have the channel. So the layered approach is followed over here in order to isolate different tasks and different mechanisms, right? So for example, at the application layer, if we want to represent an image in order to transmit it over a wireless channel, so we need a source coding in order to represent that image. So for example, we normally have JPEG standard in order to represent that image. So JPEG is a sort of source coding. Then we need to fragment that image into packets, and then after the fragmentation into packets, we need to order them, or we need to put tags on them. So that can be done at the transport layer, and we use TCP. And then after that, after the packet formation, we need to route them via different nodes, via different links. So in order to achieve that, we are actually adding some header at the network layer, and we will be using different addresses, IP addresses or internet protocol. And of course, when we will be transmitting the packets, so there can be certain errors. So first of all, we need to detect error, and then we need to correct that error. So this has to be done at the data link layer. So error correction first, maybe there are some errors at top layers, but here we can have error regarding the data link layer. So we need to detect that error, and then after the detection we can correct that error. And then of course we want to secure our data. In order to have some security, we need to encrypt the data. And finally, here comes the actual physical link, and that can be a wired link in case of wired communication, and a wireless physical media in case of wireless communication. So we need to adopt certain modulation techniques. We need to develop certain filters whenever we talk about the reception. So in order to transmit that data at a longer distance, we need certain carrier so that we can multiply our original data with that carrier in order to transmit that data over a longer distance. So for that we adopt certain modulation techniques, for example amplitude modulation, frequency modulation, and then the phase modulation. So there are a lot of different modulation techniques according to different requirements. Every technique has its own pros and cons, and then we of course when we receive the data at the receiver end, so we need to filter the noise, or maybe we need to filter the carrier signal that is not part of the actual data. So we will be designing different filters, right? So this is a sort of protocol stack. So after having the idea about the wireless communication and wireless that is enabled by certain techniques, technologies, and methodologies, so let's have an overview of the wireless LAN, local area networks. So first of all, in order to have a wireless LAN, we need a wireless transmission medium. Of course, the equipment that is required in order to build the wireless LAN, it's a bit on the higher side, and we have a data rate that is not comparable with the wired communication or wired infrastructure. And we need also license if we want to have wireless communication for a particular band. There are some unlicensed areas where we can have, but again the equipment or the infrastructure requirement for that sort of spectrum, they are very, very high because they are not common, so they are not available in the market, and we don't have standards, protocols, and different accessories in order to have communication or in order to build infrastructure in that unlicensed spectrum. They are very costly, and they are not common, so that's why the cost rises and we cannot afford to build that sort of infrastructure. But of course, in certain scenarios where we have to build an infrastructure in order to have communication on that spectrum, by using those frequencies, we can do that. So then there are certain key and important applications of wireless LAN. We can extend our LAN. For example, if we are talking about an office, and that office have the LAN infrastructure, and we want to build a wireless LAN infrastructure over that LAN. So we can do that, or we can extend the LAN. Then, for example, if there is a company who has buildings adjacent to each other, so they can also interconnect the buildings via this wireless LAN. And one of the key advantage or key application is that we can use this wireless LAN when we are on a run from one building to another building, or maybe within a building from one room to another room. So we will be having the services accessible everywhere, anytime, and within any office within the reach. We can also build the ad hoc network, peer-to-peer network, by using that wireless LAN technology. So here we have LAN, single LAN, and over that LAN we wish to build, or we want to extend our LAN in order to support the wireless communication. So here you can see at the bottom we have the fixed network, right? And we have a switch, a router, and then we have a PC. So here we have a PC, and this is a server. So this, you can say that this is the backbone, right? And then we have another infrastructure where we have user modules and control modules, right? And so this is the backbone that is actually providing higher speed data access or data services for this network. And here we have the actual infrastructure for the LAN, and you can see that we have different PCs, different servers, switches, and wireless access points that are interconnected in order to have this wide and wireless infrastructure. So we have, this is the control module, and here we have the user module, and that user module is actually connected to this wired network. And again here this control module is connected to the backbone because it has to control the wireless infrastructure, right? So you can see that this wireless communication is accessible over this LAN. So in this way we can extend our existed LAN infrastructure to have wireless LAN. And here we have built a single cell LAN, right? So here we have multiple cell LAN extensions. So you can see we have a lot of control modules and user modules, but the key difference here is that this cell is functioning on one frequency, and we have allocated another frequency to this cell, and similarly this is the third cell using another frequency. So different cells are being operated at different frequencies, and this is the backbone, as I mentioned, and this is the backbone that is actually connecting all those different cells and providing the services to those different cells. Okay, so one of the advantages, as I mentioned, that we can have the mobility, or you can say nomadic access, right? So we can have, if we have a laptop, we can carry that laptop from one office to another office, or even if we have a cross-building infrastructure, so we can move from one building to another building. So here, this is the overall wireless LAN infrastructure scenario. So you can see that high-speed backbone wired LAN. So this is the key requirement in order to provide services for wireless infrastructure. So this is the high-speed backbone, and that is wired. That can be you can say fiber optics, or maybe coaxial cable, or gigaspeed UTP. So we have the wired high-speed backbone, and that is connected to those different wireless access points. And here we have different cells. This is a cell, and here we have another cell. And this is the nomadic station. So if it is on the run, so normally if it has to move into that cell, so we should adopt certain mechanisms in order to have seamless service access, so that whenever he is moving from this point to this point, so there should not be any interruption. And we can also build the ad hoc network. So you can see that all the stations, they are connected temporarily in a peer-to-peer network while building an ad hoc network. So these are the requirements in order to construct the wireless LAN. First, we should have maximum throughput in order to use the resources effectively and efficiently. We can also have large number of nodes, and then of course we need a backbone in order to provide higher data rates, and in order to control different cells, different modules. And then we also should plan the access area, the service area, the coverage area. And one of the bottleneck in case of wireless communication is the power consumption. If I have a cell phone, you know that each cell phone, it has a limited battery. Even in case of a laptop, we have a limited amount of power that can be stored within the laptop. Then of course security, we should very conscious to our data, so we should opt reliable methods in order to ensure the privacy and security. And then there can be interference if we have multiple LANs, and over that LAN we have built a wireless infrastructure, so there can be chances that we have interference. So here comes the frequency allocation sort of problems. As we know that we have frequency allocations. For example, in case of GSM, each carrier they are actually using a particular frequency for uplink and downlink. And similarly, if we talk about the Wi-Fi or maybe Bluetooth or some other standards, communication standards or techniques, they are actually operating on a certain frequency band. So we should use the frequency band or the frequency spectrum that is not licensed, because for GSM, for Wi-Fi, for other communication standards, we have the licensed frequency allocation. So in order to avoid interference, we should use license-free frequency band. And then there is one of the main issue. For example, if we have GSM infrastructure and we are providing voice services, right? And we have different cells. So whenever a user has to move from one cell to another cell, so of course there can be interrupt in the voice services. So this is not a good sign in order to attract customers or in order to have services, seamless services. So we want to provide good quality services to our end users, to our office users, or to our organization. So in order to achieve that, we should have certain mechanism, for example, handoff. If we are moving from one cell to another cell, so that is horizontal handover. So we need to plan, we need to develop certain techniques and technologies in order to have that. But if, for example, I'm using Wi-Fi and suddenly I have to, and I'm accessing data services over that Wi-Fi, and I have to switch to GSM data services due to some problem that the access or the range of Wi-Fi is not available, right? So that is somewhat different, or we normally call it a technology switch, and we call or name it handoff, right? So in order to provide seamless services, we need to plan different techniques, technologies, and methodologies in order to provide handover and handoff. And then we should also support dynamic configuration to the end users. So as I've mentioned that when we talk about the wireless communication, or especially the wireless LAN, so there is always a very high-speed backbone that is providing services to that wireless infrastructure. So in order to have that sort of infrastructure where we can provide different services, the bottom layer is actually high-speed data network, or we can say wired data network. So that wired data network is acting as a backbone and is providing higher data rates in order to provide data services or different services onto the wireless infrastructure. So when we talk about the communication, irrespective of the infrastructure, either WAN or LAN or MAN or wireless or wired, so we need to grab certain terms, certain communication techniques, certain equipment. So we should know all the infrastructure related equipment, either it's at the backbone, or either it's at the top of the infrastructure, that is the wireless. So we should need to know all the standards and all the protocols. So let's talk about generally about the communication networks. So traditionally we have different type of network infrastructures. LAN, that is called local area network, and then we have a WAN. So traditional LAN and WAN, they are actually are, you can say, a bit older sort of infrastructure, and they provide lower data, or they support lower data rates. On the other side, we can have same infrastructure but with latest equipment, latest technology, and they support high data rate, and we name them at high speed, local area network, and then of course MAN, metropolitan area network. So if we have different metropolitan areas within a city, so in order to connect different exchanges, different portions of that city, we normally have to construct a MAN. And then we have a wide area network that is supporting high data rate. Right. So the key difference looks like over here is the speed, but this is also a matter of the requirement. For example, when we have to connect two cities, we need to use a high-speed backbone link between two cities, and we normally prefer fiber optics, right? And we can say that this lies in the category of wide area networks. And in case of MAN, we are actually having higher data rate, but within a city. For example, if we have exchanges within a city, and those exchanges, they have to be connected to a central office. So we will be using a high-speed data link, and we namely call it a MAN. And then if, for example, a company is providing all sort of services that include video, voice, and data services, so they need to build an infrastructure, build a LAN within that company, within that building, so that they can support different services within that company. And we need a high-speed local area network. So over that network, we can offer voice, video, and telephony services that actually are quality services. And then here we have the speed and the communication networks plot, right? So over the horizontal axis we have the distance, and the vertical axis we have the data rate, right? So you can see that in case of traditional WAN, we have longer distances, but the data is at the lower side, right? And for high-speed WAN, it support longer distances, but it also support higher data rate, right? So you can see the difference, right? So high-speed wide area network. So this is the huge distance, 10 raised to power 7, right? And in case of metropolitan area network, we have higher data rate, but the distance it is a bit lower as opposed to the wide area network. So let's talk about some of the characteristics of WAN, wireless area wide area network. So they can support large area, and the circuits that are being used, they are provided by the common carrier, and we need interconnected switches in order to achieve, or in order to build WANs. And then we can also have high-speed WANs. As I have mentioned, we can use fiber optics, and the technique which is used in order to have high-speed communication is ATM, asynchronous transfer mode. So here we have the characteristics of LANs, like WAN and LANs, local area networks. The devices are interconnected in order to provide services, and we can also have low speed or low data rate LAN and high speed data rate LAN. In case of high speed data LANs, we can have giga-speed switches, giga-speed cables, UTP. We have the UTP cable that support 1 gigabit per second, and we also have switches that have ports, and even nowadays within our laptops we have giga-speed Ethernet port in order to have communication over those high-speed LANs. And there are some of the differences. First, the scope of the LAN is smaller because we normally are focusing on a certain building, on a certain campus, or on a certain organization. But in case of WAN, our scope is a bit larger. Right, so we want to interconnect different exchanges within a city, or maybe different buildings that a company have within a city. So in case of WAN, and one of the key difference regarding LAN and WAN is that the LANs are actually owned by a single organization or single company or a single person, but on the other side, when they are actually built in order to provide different services. So for example, the data service is provided by one company, and the voice or telephony service is provided by the other company, and maybe the video and some other services they are being provided by the third company. So it means that in case of WAN, it is not owned by a single company. So there can be some special case. We cannot say that this is not possible, but in most of the cases, the WANs are not being owned by a single company, because the different services has to be offered over a WAN. So in that case, the different carriers and the different providers, they actually are providing their services. Maybe the infrastructure is owned by or the platform over which the services are being provided, they are being owned by one company, but the services or maybe the equipment that is required in order to provide certain services, they are not owned by a single company. And then we have, in order to have data transmission regarding the LAN, WAN, MAN, we need some sort of switching equipment, right? So in order to understand that the functionality of that switching equipment, we need to grab some switching terms. So first of all, we need to define a switching node, right? So within our network infrastructure, the switching node is a device, or you can say intermediate device, that moves data from one node to another node, or maybe from one point to another point. So the functionality of that switching device is to switch data or switch packets, right? But it is not interested with the content of the data, right? And then we should have an idea about the stations. Stations are actually end devices that are always ready to communicate, right? And each station is connected to a switching node. And if I join those two different devices, switching node and stations, right, via some physical media, so I will be having a communication infrastructure, right? So you can define a communication infrastructure, communication network. It's actually a collection of switching nodes, right? So here we have a switched network. So you can see that we have PCs, and then we have the switching nodes, right? So these are different switching nodes, right? And here we have a server PC, and this is the mainframe. So here comes certain key points regarding the this network, simple switching network. So you can see some nodes connect only to the other nodes, right? For example, 5 and 7. So here we have 5 and 7. So they are connected to other nodes. Connect to one or more stations. So some they are one or more stations. For example, this node is connected to this station, and this node is connected to this station. Node to node links, usually multiplex links. So of course, if this is here, we have to multiplex the data because we have 2 inputs, right, and 2 output also. So in order to have multiplexing, we need to adopt certain multiplexing techniques, for example, FDM and TDM. So in FDM, certain frequencies are allocated, or we have certain frequency slots separated by some frequency guard band, and then we have time division multiplexing. And in time division multiplexing, we are allocating time slot to each link. For example, for this, if I have a TDM, so I will be allocating a slot for this 5th node link, and then I will be allocating another time slot for this 7th. So maybe for one also. So we have 3 input, and if it has to be transmitted over here, then we can say 3 input and 1 output. And then we need to adopt certain switching techniques in order to achieve data communication, and that switching techniques actually are circuit switching and packet switching. So in case of circuit switching, a dedicated path is allocated between 2 endpoints, right? When we want to have data communication via circuit switching, so first of all, we need to have a dedicated communication link between the stations. The best example is whenever we want to make a call. So first a channel or trunk is allocated, and when for example, if I want to make a call, so I will pick my phone receiver, and then I will be connected to the local exchange. Then I will dial some number. So when I will be dialing, I will be allocated another dedicated path from my exchange to the exchange where my destination number is lying, right? So that is again a dedicated link, and then from that exchange to the premises of the subscriber where I want to call, there should be another dedicated link. So in that way, I will be having a dedicated link from one leg of the call to the other leg of the call, and we will start communicating with each other. And then we have the packet switching. So as I've mentioned, that in case of packet switching communication, the actual data is segmented into packets, and then those packets has to be transmitted or has to be communicated by using packet switching. So here we have different steps in order to have circuit switching. So first of all, we need to establish a circuit. So a circuit has to be dedicated in order to start the communication via circuit switching. So as I have given an example of a PSTN telephone call. So first of all, we need a dedicated link before the start of the information transfer. So one leg of the call and the other leg, there should be a dedicated link between one leg and the other leg of the call. So after the establishment of the dedicated link, we need to transfer information. So of course we will be using that dedicated link in order to transfer information, and the data can be analog voice, digital voice, or binary data. So we can have different types of data transformation. Then after we have finished, for example, after I finish calling or I have conveyed my message, so I will put my receiver on the cradle. So in that case, the resources which are allocated to me in the shape of dedicated circuit between one leg and the other leg of the call, that has to be freed and circuit has to be terminated, right? And then we have different features of the circuit switching. It can be inefficient, right, with channel capacity dedicated for duration of connection, right? The whole channel is connected for the duration of the call, and then we can also have delay prior to signal transfer for establishment. So whenever we have to make a call, either it's a PSTN call or maybe a GSM call, so you know that we have a call setup time. So this is and sometimes this delay is very, very large. So that is one of the characteristic. So once we have a dedicated link established, so network is transparent to user. So we can have a data rate, a fixed data rate, right? So these are some of the characteristics of. So as I mentioned, an example of a telephone call. So I will skip that because this is not important. Then here we have the circuit switching, right? So you can see that we have this is the local exchange, and this here, from here we have the trunk that is allocated. So this is the local loop, right? And then this is the long distance office, right? So local exchange, this is the central exchange from, so this is this here we have, you can say, from one area, and this is the other area. So you can say it can be a city, from one city to another city, or a long distance. So here we have the other central exchange, and then this is the local exchange for this subscriber, and then we have the digital PBX, or maybe this is the digitized phone. So in that way we have a dedicated link from one leg to the other leg of the call, and we have subscriber line, and exchange and trunks. So trunk is allocated, and then we have local exchange, central exchange, and here again central exchange, and this is the local exchange, and then we have the end user, right? So here we have the packet switching. So data is actually segmented into small blocks, and these blocks are called packets. And before sending, the actual message is broken into a series of packet, right? So typical packet length is 1000 octets, bytes. Packet consists of a portion of data plus there is a header in order to have the control information within that packet. At each node, packet is received, stored briefly, and passed to the next node. Right? So each node receives the packet and then retransmit it after storing it temporarily. So here we have the infrastructure regarding the packet switching network. So you can see that we have the sender device over here and receiver device over here, and we have the application that has to send data from here to here. So that application is actually sending data. So regarding the transmission, the data has to be segmented into small packets, and here we have the packet switched network, and that data will be transmitted. So here is the scenario, and we have 3 packets. So you can see that those are actually being transmitted by using the packet switched network. Right? So you can see all the packets are adopting different paths. Right? So this you can see B. Right? So here C, we have this one is going over here, and then 3 is going over here. So all the packets are adopting different paths. So here we have some of the advantages of packet switching network. So the line efficiency is on the higher side. So many packets over time can dynamically share the same node-to-node link. It can carry out data rate conversions. So if 2 stations, they have different data rate capability, they can exchange information, but in case of packet circuit switching, this is not possible. Each endpoint should have the same data rate capability. So 2 stations with different data rates can exchange information. Call when traffic is heavy. So you have the idea whenever there is a peak time in a GSM network, voice network, or in a PSTN network. So we need to dial the number again and again. So unlike circuit switching network, when calls are being blocked, packet switching still accepts packets, but with increase. But the delay will be more, but the data is being transmitted. Then we have certain disadvantages, cons of packet switching. Each node that comes in between when a packet has to be transmitted from source to destination, so each node will introduce a delay. So overall packet delay can be large, right? And each packet requires overhead information, right? So we have to be careful when we are segmenting the data into packets, right? So each packet requires overhead information in order to retrieve the data. And here we have packet switching network diagram, each packet treated independently without reference to previous packet. So each node chooses next node on packet's path, right? So here we have packet switching network by using datagram, and here we have the advantages. Call setup phase is avoided. It's more primitive, it's more flexible, and more reliable. So packet switching networks, we need to build a virtual circuit. As we mentioned that in case of circuit switching, we need a dedicated circuit, so we also need a circuit over here, but it's a sort of virtual circuit. So pre-planned route established before packet is sent. So all the packets between source and destination, they follow the same route. Routing decision not required. So in case of simple packet switching, we need a routing decision, But if we have a virtual circuit that is established before the data transmission, so the routing decision has not to be taken at the node where the packet switching has to be performed, so we can avoid the delay. Okay, so advantages of virtual circuit: establishing a virtual circuit in original order. So in case of packet switching, you can see that the packets from here to here, they can arrive in different order. But if we have packet switching with virtual circuitry, then packets should arrive, or they arrived in original order, and they arrive correctly, and of course as a result the transmission is rapid without routing decisions, right? So here you can see the here we have the datagram approach, and here we have the virtual circuit approach. Okay, so that's all for today's lecture. So today we talked about the wireless communication, and we discussed why we need wireless communication, and we also compared wired and wireless communication and the enabling technologies that are required in order to have the wireless infrastructure. And we also touched wireless protocol layer, and then we talked about how we can establish a wireless LAN over an existing wired infrastructure. Then we talked about different communication techniques that actually are being used at this backbone network, that is the wired network, that is circuit switching and packet switching. And we finally talked about the advantages and disadvantages of those different techniques. So that's all. Apna khayal rakhiyega. Allah Hafiz. Assalamu alaikum.